All right, so we are always going to put our angle down in the lower left-hand corner. So if we have 33 degrees down here for angle B, and the side across from B is 14, this side is 23. So because this is smaller than this, there is the possibility of two triangles. So this would be angle A, this would be C. So that's one possibility. The other possibility is if we swing that 14 in, so that we have an obtuse angle instead of this is still 33 degrees here, but now this is going to be an obtuse angle, whereas it's more of an acute angle in the first possibility. So we will have two triangles here. So we'll have to find the angle measures A and C for both and side length C. So if we start with our first triangle, so let me move that one to the side for now. So I can do the sine of 33 degrees over 14, so side length across from the angle. That will equal the sine of A divided by 23, and we can solve for A. So we'll cross multiply, we'll have 23 times the sine of 33 degrees equals 14 times the sine of A. And so we'll divide by 14. And then we'll do the inverse sine to solve for that angle measure. So the inverse sine So second sine, let me get back to my home screen. Okay. So second sine, to do the inverse sine, 23 times the sine of 33, close the parenthesis, divided by 14. So we see that angle A would have to be approximately 63.48 degrees. In our first triangle. Okay, so then to find angle C, we can do 180, since all three angles in a triangle add to 180, minus the 33, minus 63.48. So we have 83.52 degrees. And then we can set up a ratio to solve for the length of side C, now that we have that angle measure. So we'll stick with sine of 33 over 14, since they gave us that in the problem. And now we'll do the sine of the 83.52 divided by side length C, and we'll cross multiply and solve. So C is going to equal 14 times the sine of 83.52 divided by the sine of 33. So we're going to get 25.54 approximately for the length of side C in triangle number 1. Now again, this is one possibility where it kind of comes out this way. We've got acute angle A, or we can swing that arm back in here so it looks more like this, and A is going to end up being obtuse. And the way we find it is it's going to be supplementary with this. So we're going to take 180 degrees minus that angle to find the new one. So 180 degrees minus the 63.48 degrees gives us 116.52 degrees for angle A now. So if we do 180 minus that, minus the 33 they gave us, that tells us that angle C would have to be 30.48 degrees. Because all three still have to add to 180 degrees. And now we can use that to find the measure of side length C again. So we stick with the sine of 33 over 14 because they gave us that in the problem. And now we'll set up the ratio of the sine of 30.48 over C. And so if we cross multiply and divide, C will equal 14 times the sine of 30.48 divided by the sine of 33. Again, always making sure our calculator is in degree mode since we're entering our angles as degree measures. And so this time we get that C is approximately 13.04 units long. All right, so in this next one, we've got an obtuse angle 122 degrees. So that's angle C, and across from it is 18. The other side they gave us is 12. So because this is bigger than this, we only have one triangle this time. So we only need to solve for one triangle, so we can cross out this. It's impossible to have a second triangle because this side is bigger than this one. So I'll set up the sine of 122 degrees over the side across from it has to equal the sine of angle A that we need to find, divided by its opposite side length, which is 12. So to find A, we're going to have to do the inverse sine. So it'll be 12 times the sine of 122 degrees divided by the 18. So second sine to get the inverse sine, 12 sine 122 divided by 18. So we get approximately 34.43. So then we can do 180 minus 34.43 minus 122 gives us 23.57 for angle B. And now we can use that to find side length B. So again, sine of 122 degrees over its opposite side length of 18 that they gave us in the problem has to equal the sine of 23.57 divided by side length B. So if we cross multiply and divide, B will equal 18 times the sine of 23.57 divided by the sine of 122 degrees. So B is approximately 18 times the sine, 23.57. Close that parenthesis. Always make sure you close that parenthesis. Divided by sine of 122 degrees. Approximately 8.49 units for side length B. All right, a couple more examples here. All right, so on this next one, again, we're always going to try and put our angle in the lower left-hand corner just to kind of be strategic about this. And then the side across from it here is 2.5. This side is 4. So we're thinking 2 triangles here because this is smaller than this one. So if we start to try and solve, we've got sine of 58 degrees over 2.5 has to equal sine, so I forgot to finish labeling, sorry. Because the side length A is 4, this would be angle A across from it, and so then angle C would go here. So we'll say sine of A over 4. So then to find A, we would have to do the inverse sine of 4 times the sine of 58 degrees divided by 2.5. So A is approximately second sine, to get the inverse sine, 4 times the sine of 58 degrees divided by 2.5. Non-real answer, or your calculator might say error. Well, this tells us there's actually no triangle possible with this information. So that can happen too, remember. Maybe it's not even one triangle that's possible. So no triangle possible there. Okay, so let's try our next one. So we've got 72 degrees down here for alpha. And then side across from that is 8.1. And then this is 8.3. And so here's B. And here's C. So we do think 2 triangles because this is smaller than this. So we are going to have to also consider, you know, if we swing that arm in and have it be more like this. So we are going to have to solve for the second triangle here if we can. All right, but we'll start with sine of 72 degrees divided by its opposite side length of 8.1 has to equal the sine of B divided by its opposite side length, which was 8.3. So to find B, we're going to have to use the inverse sine since we're solving for the angle measure. It'll be 8.3 times the sine of 72 degrees divided by the 8.1. So second sine, to pull up the inverse sine, 8.3 times sine of 72 degrees divided by 8.1. And so we get 77.04 for the measure of angle B. So then we can do 180 minus the 77.04 minus the 72 to see what that leaves us for that third angle measure. So we'll get 30.96 degrees. And then we can set up the ratio to find the length of that missing sine. So we can say sine of 72 degrees over 8.1 that they gave us in the original problem. And now we know the other angle is 30.96 degrees over its missing side length C. So if we cross multiply and solve, C will equal 8.1 times the sine of 30.96 degrees divided by the sine of 72 degrees. So we get approximately 4.38. Okay, so we do have to check out the other triangle now. So if we do, 180 degrees minus angle B, which was 77.04. That'll get us the new angle B. So 180 minus 77.04 gives us 102.96 degrees. So then 180 minus that minus the 72 degrees, that is angle A that gave us in the problem, gives us only 5.04 degrees for gamma. And so now we'll have to do the sine of 72 divided by the 8.1 from the original problem equals the sine of C or gamma, whichever one you want to do. Oops, sorry, I forgot. That's what we know. We got to plug that in. 5.04. And then we're looking for length of C. So C will equal 8.1 times the sine of 5.04 divided by the sine of 72. And so we get approximately, so 8.1 times sine 5.04 divided by sine of 72. So we get approximately 0.75 for the length of C. So there's our two triangles. All right, one quick application problem. So engineer wants to construct a bridge across a fast-moving river. So there's my river using a straight line segment between 2 points that are 148 feet apart. He measures angles when sitting at them from A and B. So from A it's 63 degrees. So we'll make this A, and then from B it's only 41 degrees. So 63 degrees, 41 degrees. So if we do 180 minus 63 minus 41, that tells us that this one must be 76 degrees. And they want to know what is length B, because they're asking for how far is the point from point A to the other side of the river. So from here to here. So this would be length B because it's across from angle B. So we'll set up the sine of 76 degrees divided by the 148 they gave us in the problem equals the sine of 41 degrees over length B. So B is going to equal 148 times the sine of 41 degrees divided by the sine of 76 degrees. So then B is approximately 100.07 feet. And that's the law of sines. So we just always have to consider, is there a possibility of two triangles? So that's when we have that side-side angle, and the side they give us is across from the angle is less than the other side. We've got to consider that second triangle.